Hi guys, it's Sal Ferrara. I just want to go over a couple of things before I get started. Number one, we're going to be doing tonight the quiz for homework, quiz number 8 and quiz number 9, and Tom Henry, which will be the master exam number 1, questions 16 through 30. Tonight's lesson will be quiz number 7. So tonight's lesson, we're going to go over quiz number 7. Now before I get started, I just want to let you know what's going on with the school, and I give you a little comfort. Right now, for the next 2 weeks, for this Thursday and next week, Tuesdays and Thursdays, we will have videos for the school. Okay? After that, you will be notified. I will take it on my own to do a Saturday class for you guys on all the math and everything. Usually I do electrical calculations class, so we'll do a Saturday electrical calculations, and also I'm going to talk to Mr. Torino and see if we can do another 2 nights, just so you're comfortable in this. But you also have a responsibility as a student to complete all these, all the quizzes and tests. Then what's going to happen is you're going to go back to the original day 12, that night 12, and then you're going to be doing still your PowerPoints and your homeworks. Right now I'm just giving you quizzes and tests, so you guys at least are going into the code book. There's going to be math. If there's math, a lot of it is in the Tom Henry book. So I want you guys to make sure that you go into the Tom Henry book, read the whole chapter. It's very, 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 very important to read the whole chapter. Okay? So, that being said, what I like to do right now is, you should have got this email to know that there is a video and there'll be directions on exactly how to do this. And that's it, because you're already here, so you know how to do it. So that's it. So let's go over quiz number 7, and we're going to take it nice and slow, and everybody will understand exactly what the heck's going on over here. Okay? So question number 1, you got a 14 copper is used for a motor. How do we do this? Very simple. We're going to go to 430.72b, like in boy, and you're going to see if you have it, and you also, I'll give you a couple of seconds. Get your code book out. Okay, you're going to need your code book. You could also stop the video also if you wanted to, so we can continue. That's up to you guys. So you're going to go to 430.72b, and you look on the bottom, it says maximum rating of overcurrent protected device in amperage. And if you read the question, it talks about extend protection for the number 14 between the motor start and remote stop. Okay, in this one, you're going to go to column C, and if you go to column C for a number 14 wire, you're going to see it's 45 amps. So the answer is C, 45 amps. Again, I would take this one and know it. Okay, it's very important. Number 2, this one, keyword is service factor. So now if we're in service factor, right, or overloads, we're in 430.32, which talks about this. So I'm going to erase this. I want everybody to go to 430.32A1. And if we look, when we have 1 horsepower or more, but not marked with the service factor or temperature rise, how do we know? So we go to 430.32A1, and if we go there and we read it, which I'm going to go there right now, 32A1, it says, and there's an actual little table over there. You can see it says motors with marked service factor 1.15 or greater, 125%. Motor with marked temperature rise, 40 degrees Celsius or less, 120. All of the motors. So here, they're not telling you It's not marked with the service factor, and it's not marked with the temperature. So we're going to take the 1 horsepower motor, and the answer is 115%, which says all other motors. Okay, very simple. Okay, so again, you'll see that all other motors, 430.32A1. Okay. Number 3, what is the minimum size THWN copper conductor? As soon as you see conductor, we're in 430.22. And let me just back up a second. 430.6A1 sets the rules, FYI. Sets the rules for motors. And basically what it says is that for the ampacity, which is your conductor, ampacity, right? And that's 430.22. For your short circuit, ground fault protection, that's 430.52. And for disconnect switches, disconnects, which I believe is 430.109. Let me just make sure, but I'm almost positive that's it. I might be a little rusty at this, so I haven't even looked at the books, but I'm almost positive. Let me just make sure. 430.109. Yes, I believe it starts right there, 109. Okay, and it goes into the requirement of disconnect switches. Okay, so with 430.6A1 states is this. Very simple. I'm going to go, and I want everybody to go to the code book. Everybody go to 430.6A1 right now. Okay. Well, 430.6 talks about the ampacity and motor rating determination. Okay? And A says this. General motor applications. For general motor applications, current ratings shall be determined based on A1 and A2. So, I'm talking about A1. So it says for other than, I don't know, motor built for low speed, which we're not really concerned, you shall use table 430.248, which is single phase, 430.248, which is single phase, and 430.250, which is 3-phase, which is your actual horsepower rating, instead of the nameplate rating. So I'll read it. The tables in 248, 250 shall be used to determine the ampacity of the conductors, the amperage rating of the disconnect switch, and the short circuit ground fault protection, instead of the actual current rating marked on the motor nameplate.
Call from Nick Man Electric, cousin Jimmy friend.
Sorry about that. Make sure all your what do you call it, are off. So, if I have a nameplate and it says the voltage 208 volts, well, let's go 120 volts, let's keep it simple. 120 volts, FLA, 14, I'm just making up numbers, 14 amps, and the horsepower, 5 horsepower, and this is a single phase, okay? I don't use this nameplate, I don't use the FLA to find the ampacity, the short circuit ground fault, or the disconnect. What I do use, I use the horsepower rating. So, let's go to, it's single phase, we're going to go to 248, and I just want to show you so you understand. So everybody go to 248. And if we look at 248, and it's 120 volts, and it says 115 volts, which is actually up to 120, you'll see it's 56 amps. This, based on 430.248, is 58 amps. Now that amperage, we're going to do something with it. We're either going to do it based on the ampacity, which is a calculation, the short circuit ground fault protection, which is another calculation, or your disconnect switch, which is another calculation. But we use this number. We do not use the FLA number. Okay, that's very important. So I'll just tell you something else, which is pretty interesting. 430.6A2 says that you shall use the nameplate FLA for the overloads. -2, 430.6A2, for overload you use the FLA, the nameplate. That's the only time they use the nameplate. Now there are exceptions to the rules, but this is the general rule. I'm not going to go into it because I could spend the whole night doing this. Just so you guys have an understanding. So let's just reiterate what we learned. Step 1, you look at the nameplate. And a question says, if a question on the test or it says the horsepower, they give the horsepower and they give the FLA, they give both. They give the horsepower and the FLA. You must use the horsepower. That's it. The FLA you're going to use for the overload. Very simple. So you're going to use the horsepower, again, for the ampacity, which is your conductor size, the short circuit ground fault, which we'll talk about a little while, and for your disconnect switch. That's it. Show's over, monkey's dead. That's how simple this is, guys. Okay, so let's get back to the question, and let's see what we're going to do here. So here, we have a 30 horsepower. What is the minimum size conductor fed to a 200 amp, 3-phase, 30 horsepower? 3-phase. So we're going to go to 430. We have and let me just write it down so everybody can see. We have a 200 volt motor, 3-phase, and it's 30 horsepower. 30 horsepower. They want to know what size conductor. So if we go to 3-phase, we're going to go to 430.250. Everybody go to 430.250 right now. Okay. Now we look up 3-phase, which we're in, and with how many horsepower? 30. And you don't have the crooked finger syndrome. Make sure you use a straight edge, okay, a ruler or something. A lot of people fail their tests because they're using their finger and you use the crooked finger syndrome. I'm not making this stuff up. So make sure you have a straight edge. Very, very, very important. So we look up the 30 horsepower, and it's 200 volts, and we look up it's 92 amps. So we're going to take the 92 amps. We got to times it by something. And if you go to 430.22, it says for one conductor, for not more than one conductors, okay, more than one motor, I'm sorry, not more than one motor, it's 125%. So we times that by 1.25, and we come out with 115 amps, okay? And the question is, what size conductor? So we're going to go to 310.15 B16, and if you look it up, it's going to be B. The answer is B, a number 2 wire. A number 2. Okay? And it also says it's in the 75, but you guys already know that. Anything above over 100 amps is automatically 75-degree answer. You don't go into the 60 unless there's other things going on. Okay? Any questions? No, of course. Thank you. Okay. Number 4. If two motors supplied by the ampacity equals sum, of the boat motors plus, the answer is A, 125%. So again, that 22 is for a single motor, and 430.24 is more than one. Okay? Several. 2 motors, 3, 4. Who the hell cares? Okay? However, what you do is you take that largest FLA, okay, not the horsepower, you take the largest FLA once you figure out what it is, and you have to times it by 125%. So let me give you an example. And I'm just making up numbers. I'm not going in the code book. I'm just making up numbers. Let's say a 2 horsepower, or 1 horsepower, 115 volts is equal to 24 amps. I'm just making up numbers. And a 3 horsepower single phase is equal to 38 amps. Well, what you're going to do, you're going to take the largest of the two, because we're in dot 24. You times this, 38 times 1.25, which is equal to, and I'm sorry, and I have to use my phone, which I hate doing. I don't have a calculator on me right now, but it doesn't matter. We'll take the 38 times 1.25, which is 47.5. So we added the 125%, and then we add up the 24. And if we add that up, it's 5, 11, that's 71.5, and that's how you would amps. And this would be a feeder if you wanted to figure out the feeder size. Okay? Now, if you were doing each one, you would take, if this is motor number 1, this is motor number 1, motor number 2. Here you would take the largest one. I'm sorry, you would then, if you want to do each motor separate, again, this is motor number 2, then you would have to do number 1, the same thing. You take the 24 amps, times it by 1.25, and that would equal 30 amps. Okay? So these are for branch circuits. This is a branch circuit, and this is a branch circuit. But if you combine them, this would be a feeder. Right? And that's how you do it. Again, read the Tom Henry book. I'm not going to go into more of this because you already should have read the Tom Henry book on this. But I just wanted to give you an idea exactly, to listen to me. So sometimes when you listen, you can, just reading sometimes doesn't make sense. But Tom Henry does a great job. Okay? So let's continue. So the answer for this is 25%. Okay. Number 5. What is the maximum time delay fuse? Okay. So can I erase all this? Okay, I'm going to erase all this right now, okay? So number 5, and I'm going to leave this up here so we know what tables to go to. What is the maximum time delay fuse for, we have 3 motors. So let me just draw a picture. We got a panel. And we got a, what is it, maximum time fuse? And we have this. And we're feeding, and we're coming into 1, 2, 3 motors. Just keep it simple. 1, 2, 3 motors. Okay, everybody see that? And we got motor number 1, 2, 3. And they want to know what the maximum times, what is the maximum size time delay fuse permitted for a number 1 copper for the feeder. So make believe this is a fuse, okay, which it really doesn't look like a fuse. If you want to make it look like a fuse, we go like this, okay, like this. Okay, it's a fuse, connected to the fuses, okay? It's irrelevant, but you could show a picture. So we want to know the fuse. Time delay fuse, feeding these motors. And then, of course, you're going to have a disconnect switch here for each one, or a breaker for each one, right? And we'll talk about that a little later. So let's just continue. We know this is a 10 horsepower. We know this is a 2 horsepower. Oh, we got 2 of them. 2 horsepower. I'm sorry. 15 horsepower. We We got another 15 horsepower. And we have two 20 horsepower. 20 horsepower, 20 horsepower, okay? So we got 110, two 15s, and two 20s. Everybody understand that? So now we're going to go to, we want to find out the fuse, which is a short circuit ground fault protection. We're going to go to 430.52. Everybody go, let's go to 430.52. Go in your book to 430.52. Okay. And if you look at 430.52, there's a table. And on the left-hand side, it says single phase, okay, and it has for non-time delay, dual time, non-time delay fuse, a time delay fuse, an instantaneous, and an inverse time breaker. The inverse time breaker is your actual regular breakers that you use every day, like a QL, a THQB, an MHT, regular breakers that we use every day. Okay, they're called inverse breakers, okay? I'm not going to go into it again. When you read the Tom Henry book, he'll go into it more. But what I want to understand is, we know this is three-phase, okay? And we know the voltage is on this one. And I just lost my Como se llama here. Hold on a second. I don't know what I did with my paper. Hold on, guys. Okay. And we know this is 480 volts. Okay? And it's three-phase. So we're going to go to 430. We're going to go to 430.250. Okay, the table. 430.250 because it's three-phase. And we're going to look it up. We know that at 10 horsepower, and if we go to 430, everybody go to 430.250. Three-phase, 480 volts. It says 460, which is actually 480, same thing. Okay, and if you go, the 10 horsepower is 14 amps. The 15s are 21 amps. 21 amps. And these are 27 amps. Okay. So what we're looking for here is we're looking for the short circuit ground fault protection. So when we find the short circuit ground fault protection, it gets a little confusing, but it really isn't. Remember, a tree grows. If you look in the Tom Henry book, he shows you the tree growing, so you must go up with your number to an actual 240.6 number, which is your overcurrent protection, a real size breaker or fuse. And what it says in 430.52 C1 exception number 1 says that if it's not a standard size fuse or breaker, you're allowed to go up to the next standard size. So let me give you an example. If the final answer, just making up numbers, was 47 amps. If we round up 47 amps, what's the next size overcurrent protection? 50, right? 50 amps. If it was 109 amps, what's the next standard size? I believe it's 110 amps. If it was 32 amps, we go to 240.6 again, and we see it'd be 35 amps. So you round up, okay, and that's what you're allowed to do. So what we're going to do, we're going to add these up, okay, and then we're going to go up, and then our final answer will go down, and I'll explain it very simple. So which is the largest one out of all these? The 27 amps. So we're going to take the 27 amps, and we're going to times it by something. And if we go to 430.52, the table, and we're looking for a time delay fuse. So if everybody goes there, you're going to see a time delay fuse for three-phase AC poly motors for a time delay fuse is 175%. Does everybody see that? Okay? 100 for a time delay fuse, called a dual element. So we're going to take this number and we're going to times it by 175%. Okay? And when we multiply it, we're going to take, which is the largest one, 27 times 1.75 equals 47.25. So let me ask you a question with my statement before. 430.52C1 exception 1 says you're allowed to go up, up, up to the next standard size breaker or fuse. What's the next standard size breaker or fuse? Go to 240.6 and it'll tell you 50 amps. So here we're going to cross this out. We'll just make a little line and it equals 50 amps. So we're done there. We figured it out. Now we're going to add up all the rest. And because we went up, the final answer has to go down to this next standard size breaker or fuse. So we got 50 amps. Now we just add these up. We got the 27. We only do it once. We only multiply the 430.52 only once. So we take the 27, we take the 21, and the 14 amps. And we add it up. This is 8, 9, and 3 is 13. Carry the 1. That's 3, 5, 7, 8. Am I correct? Is that right? Did I do that right? Nope, I did it wrong. I did it wrong. This is 1 up here. So that's 6, 8, 10, 12, 13. 133 amps. Well, let me ask you a question. Is that a standard size breaker or fuse? No. So we went up here. So what must we do, guys, over here? We must go what? We went up, we must now go down. Down for this right here. So we're going to go down. And if we go to 240.6, everybody go to 240, well, I'll tell you what it is. It's irrelevant. 240.6, the next standard size, if we go down, is 125 amps. So that's how you do this problem. So let's just reiterate what we learned, and that's it. So the answer to this is C. So again, let's see what we did. This is for over short circuit and ground fault protection in 430.52. Step 1, 430.52. We're going to take the horsepower, step 2, and we're going to look up what the horsepower is based on the voltage. This is 480, 3-phase. We find out that 10 horsepower is 14 amps based on the table. The 15 is 21, the 15 is 21, and these are both 27. Then I say to myself, self, which is the largest motor. And we see here that one of these are the largest, so we can take either one, it's irrelevant. So I take this one here, motor number 5. So I take it, and I have to times it by something. And we're looking for a fuse. So we go to 430.52, and they say for a time delay fuse, you multiply it up by 175%. And so you know where this is, and I just want to clarify this because these are for feeders, and we're in 430, and I'll just give you the code section so everybody knows. And just give me a second, please. We're in 430.62, rating or setting a motor load. Okay, that's just where I'm getting this information from. Okay, just FYI. If you're concerned, where am I getting this information from for a feeder? Okay, so I times it by 175%. It's 47.25. When I'm looking for a overcurrent protection device, either a breaker or fuse, whatever that number is, I have to make it a standard size. So I have to go up Or if it is a standard size, you leave it alone. 47.25, we go to 240.6, it's a 50 amp. Now I take the other ones, the 27, the 21, 21, 14, I add it all up, it's 133 amps. Again, for an overcurrent protection device, either a breaker or fuse. We're not talking about conductors here. We're not talking about ampacity. We're talking about overcurrent protection, short circuit and ground fault protection. Very important. I find it's 133 amps. I went up here. Now I must go down. It's 125 amps. That's it. Simple. Read the Tom Henry. You'll understand it. Okay. Let's go to the next question. Number 6, a horsepower rating. I'm just going to give you the code section, 430.83. Okay, just read it. There's no math in that one. Okay. Question number 7. Now we're in 440. We're in Article 440. So let me just erase this and just go over this, which 430 is motors, and we'll talk about hermetic compressors, which is a little different. Okay. We're in Article 440 now. I'm still going to leave that up. 440. And basically what the code says with Article 440 is that you shall use the nameplate rating. And it's called the branch circuit selection current. Branch circuit selection current. Branch circuit selection current, BCSC I think it's called. And let me just make sure if I go to 440, it should be in a definition, I'm almost positive. Let me see where it is, hold on. Here it is, if you go to 440.4C, branch circuit selection current, okay? Basically what it says is you gotta use the nameplate. So how many times you guys have a condenser, right? You go outside, you look at the nameplate of the condenser and it says something like this. Okay? You'll see it says minimum ampacity, 17 amps, maximum overcurrent protection device, 30 amps. Okay? And you'll see other information on this condenser. So what they're telling you is, very simple, is that you could run not technically, you shall, if you go to 310.15b16, that you could run a number 17 amp wire, 17 amp ampacity on a number 14 wire. And I forgot to explain this a little earlier, so let me explain right now, is that if you look at 310.15b16, everybody go there. Everybody, let's go to 310.15b16. Okay, the ampacity. I'm going to go to it, you're going to go to it, we're going to go to it, and we're just going to look at it for a second. Okay? And if you notice in the number 14, and I know number 18 and number 16 have it also, but let's look at a number 14, a number 12, and a number 10. Okay? And you notice there's a little asterisk, 2 asterisks against each of those. The number 14, the number 12, and the number 10. And if you go below, you'll see it says, with the 2 asterisks, refer to 240.4D for conductor overcurrent protection. Because remember, 240 is overcurrent protection. Article 240 is overcurrent protection. 310 is your conductors, right? The code is made very specific, okay? So if we go to 240.4D, and I know it by heart, fortunately or fortunately, it says, unless specifically mentioned in E or G, okay, you shall use 310.16 for the overcurrent protection, unless specifically mentioned E or G. For number 14, you got to use a 15 amp overcurrent protection. For a number 12 wire, you got to use a 20, and for a number 10, you got to use a 30. So what happens is motors, and also hermetic motors, 440 and 430, supersedes or modifies the general rule. So if you go to 240, 17.4G, which is a laundry list, it modifies the general rule. So that's how come the minimum capacity is 17 amps, and if you go to 310.15B16, a number 14 at 60 degrees is a number can only hold 15 amps. But if you look at 75 degrees, as long as both ends, okay, 110.14 C1 talks about this, both ends have the same, about 75 degrees, then you could go to the 75 degree column, and then if you see that, I could actually use a number 14 wire for this condenser. You're going to say, no you can't. Yes you could. Because it amends the general rule. Motors amends the general rule. And then the overcurrent protection, and say I use a breaker. I'm going to use a 30 amp breaker for this, and this is a conductor. And it's no problem at 75 degrees Celsius. And it should be no problem. Remember, what a motor does is, it does two things, actually three things. What the motor is protecting for the breaker, okay, is for the conductor, it's protecting against a short circuit and ground fault protection. So that's your breaker. Your overloader, your thermal protector, is protecting your equipment. So is it a motor circuit or a hermetic refrigeration circuit better than a regular lighting circuit or a regular receptacle circuit? I think so. So that's the reason why motors are different, okay? And you hear this all the time. Well, you can't put a 40 amp on a number 12 wire. That's against the rules. No, it's not. And you should. There's nothing wrong with it. Now, if there's specs or other requirements,